Cardano is a project that began in 2015 as an effort to change the way cryptocurrencies are designed and developed. The overall focus beyond a particular set of innovations is to provide
a more balanced and sustainable ecosystem
that better accounts for the needs of its users as well as other systems seeking integration. In the spirit of many open-source projects,
Cardano did not begin with a comprehensive roadmap or even an authoritative white paper.
Rather, it embraced a collection of design principles, engineering best practices, and avenues for exploration. These include the following: separation of accounting and computation into different layers, implementation of core components in highly modular functional code, small groups of academics and developers competing with peer-reviewed research, heavy use
of interdisciplinary teams including the early use of InfoSec experts,
fast iteration between white papers, implementation and new research required to correct issues discovered during review, building in the ability to upgrade post-deployed systems without destroying the network, development of a decentralized funding mechanism for future work, a long-term view on improving the design of cryptocurrencies so they can work on mobile devices with a reasonable and secure user experience, bringing stakeholders closer to the operations and maintenance of their cryptocurrency, acknowledging the need to account for multiple assets in the same ledger, abstracting transactions to include optional metadata in order to better conform to the needs of legacy systems, learning from the nearly 1,000 altcoins by embracing features that make sense, adopt a standards-driven process inspired by the Internet Engineering Task Force using a dedicated foundation to lock down the final protocol design. Explore the social elements of commerce. Find a healthy middle ground for regulators to interact with commerce without compromising some core principles inherited from Bitcoin. From this unstructured set of ideas, the principals working on Cardano began both to explore cryptocurrency literature and to build a tool set of abstractions. The output of this research is IOHK's extensive library of papers, numerous survey results such as this recent scripting language overview, as well as an ontology of smart contracts and the ScoreX project. Lessons yielded an appreciation for the cryptocurrency industry's unusual and, at times, counterproductive growth. First, unlike successful protocols such as TCP/IP, there is little layering in the design of cryptocurrencies. There has been a desire to preserve a single notion of consensus around facts and events recorded in a single ledger, regardless of whether it makes sense. For example, Ethereum has encumbered enormous complexity to a social world computer that suffers from trivial concerns potentially destroying the system's ability to operate as a store of value. Should everyone's program be a first-class citizen regardless of its economic value, cost to maintain, or regulatory consequences? Second, there is little appreciation for prior results in mainstream cryptographic research. For example, Bitchair's delegated proof of stake could have easily and reliably generated random numbers using coin tossing with guaranteed output delivery, which is a technique known since the 1980s. See the seminal paper by Robin and Venor. Third, most altcoins, with a few notable exceptions such as Tezos, have not made any accommodation for future updates. The ability to successfully push a soft or hard fork is pivotal to the long-term success of any cryptocurrency. As a corollary, enterprise users cannot commit millions of dollars worth of resources to protocols where the roadmap and actors behind them
are ephemeral, petty or radicalized.
There needs to be an efficient process through which social consensus can form around a vision for evolving the underlying protocol. If this process is enormously burdensome, fragmentation could break the community apart. Finally, money is ultimately a social phenomenon. In the effort to anonymize and disintermediate central actors, Bitcoin and its contemporaries have also discarded the need for stable identities, metadata and reputation in commercial transactions. Adding these data through centralized solutions removes the auditability, global availability and immutability, which is the entire point of using a blockchain. Legacy financial systems, such as those composed of SWIFT, FIX and ACH, are rich in transactional metadata. It is not enough to know how much value moved between accounts. Regulation often requires the attribution of actors involved, compliance information, reporting suspicious activity, and other records and actions. In some cases, the metadata is more important than the transaction. Hence, it seems reasonable to infer that the manipulation of metadata could be as harmful as counterfeiting currency or rewriting transaction history. Making no accommodation for actors who want to voluntarily include these fields seems counterproductive to mainstream adoption and consumer protection.